VRMS. Okay, that is root mean square speed. Okay, VRMS stands for root mean square speed. Now, what does this mean? Okay, what is meaning of root mean square? Khatarnak phrase છે એનો શું meaning થતો હશે? Let's find that out first. Okay, so basically this term comes from statistics. You all can see the screen, right? This term comes from statistics. Okay, so let's first of all calculate what is meaning of root mean square. So first of all, it says that you have to take a root, okay, root of mean that is average. Okay, so root of average of what? Average of square. Root of average of square. So what that means is, suppose let's say you have got 3 observations, x1, x2 and x3. Then you first of all find the average of their squares. See, these are the squares. How do you find average? By dividing by 3. Again, I go through the steps. First step is you take root, okay, of what? Root of average. Average એટલે suppose 3 observations છે, 1, 2 and 3. So then you have to divide by 3. But average of what? Average of squares. So x1 plus x2 plus x3, no, not that. Average of the squares. Did you understand this? This is what is called root mean square, right? So you know, I always advise everyone to remember it like this. It is the root of mean, એટલે average of squares. That is called RMS. RMS, root of mean of square. Okay, so suppose let's say in a classroom there are 5 students again. Okay, let's say in a classroom there are 5 students, and this is the number of pens that they have. Suppose first one has 0 pens, second one has 1 pen, third one has 2 pens, fourth one has 1 pen, and fifth one has 3 pens. Okay, so these are the number of pens that they have. Now if I want to find the RMS of pen, okay, so now we are finding pen RMS. Okay, pen RMS, that is the root mean square of the number of pens. So let's see what we will have. First of all, we should take the square root of what? Of the average of squares. Okay, hopefully everyone understood that. So in this particular case, this is going to be 0 plus 1 plus 4, 5 plus 1, 6, 6 plus 9, 15, and then divided by 5. So this is root 3, that's it. So pen RMS equal to root 3. Did you understand? This is the meaning of VRMS. Okay, but I mean any kind of RMS. Now how do you make it VRMS? How do you make it VRMS? Let's see. Suppose that this is a container, in that there are lots of tiny molecules going here and there with different speeds. Let's say this one has v1 speed. I repeat, speed, not velocity. I'm just talking about speed. Okay, like this, there are different speeds. So what do we do? Suppose there are 5 molecules only, then we first of all take the square of individual and then find average. Did you understand this? And then we take square root. So this is nothing but VRMS. Clear? મેં આ જેવું ડ્રો કર્યું, જેવું લખ્યું એવું તમે લખી લો. એ જ એનું એક્સપ્લેનેશન છે, કઈ વર્ડ્સમાં હું બધું બોલવાનો નથી, બરાબર ને? Okay, so suppose 5 molecules, and this is how we find. Let's say instead of 5 you'd have billions of molecules. Okay, I'm sure you understood that. Instead of 5, let's say you have what, billions of molecules, right? then you can just write it as addition of v1 square v2 square up to vn square and then divided by n. નંદિની ટાઈમ પર લખી નાખવાનું. So this is an example. Again, it is the root of mean of squares. Okay. Now, what is the value of root mean square for a particular gas? Okay, you have already derived the formula or hopefully studied the formula in chemistry, right? We will derive it shortly here. See, to understand what is the root of mean of square, I'm going to start from a slightly different place. I will start with translational kinetic energy. Start with translational kinetic energy of the gas. Okay, I'll start with translational kinetic energy of the gas. So, suppose in a gas there are n molecules. How many molecules? N. Don't forget, n molecules. Mu moles. Right? આ બધું last time નું જે છે એ જ છે, બધા symbol. So, translational kinetic energy of the entire gas is going to be as follows. 1 by 2 mv1 square for the first molecule plus 1 by 2 mv2 square for second molecule. Did you understand this? But we know that translational kinetic energy of the gas is equal to 3 by 2 mu RT, isn't it? We derived it last time. Translational kinetic energy of the gas is 3 by 2 mu RT, right? Okay, so this addition is 3 by 2 mu RT. Now what is common? Because mass of every molecule is same, m is common here, so I will get m common. 2 cancelled everywhere because there is a 2 on the right side as well. So this is what we got, is equal to 3. Now instead of mu, we can write something else, okay, in form of n. See, we have mu equal to n upon Na, isn't it? Right? So I'm going to put, instead of mu, I'm going to write n upon Na into R into T. Okay, so if I want to find Vrms, okay, everyone have a look. If I want to find Vrms, I should get it in this form. હવે આના જેવું form લાવવાનું જ આપણે, આના જેવું form લાવવાનું. Okay, so it's very easy to do. I will simply divide this n on this side. So next step is going to be v1 square v2 square added up to v capital N square divided by capital N. This n I've basically divided on this side. Okay, so this is equal to 3 as it is, RT as it is, divided by M and Na. Right? Raise your hand if you understood this step. Okay, right. So now, hopefully you also remember what is R upon Na. Hopefully you remember what is R upon Na. R upon Na is Boltzmann constant Kb, right? So that's why the left side, which is nothing, listen to this, left side, if I take the square root on both sides, I took square root on both sides, R upon Na is Kb, right? R upon Na is Kb, as you all got that. So we have left side equal to this. Now what is this left side? What's this left side? Have a look. It's nothing but Vrms. So we have found that Vrms of the gas is equal to under root 3 kBT divided by small m. That's a very important relation. Okay, what are the terms? VRMS stands for the RMS speed of molecules. Okay, of the gas, of course. Right? See, this is a kind of an average. Listen to this. RMS is one kind or one way to find an average. Okay, but statistically it's slightly different. It's not just direct average. See, what would be direct average? V1 plus V2 added up to Vn divided by n. This is direct average. But we are not finding direct average, we are finding VRMS. એનું એક reason છે, હમણાં કહું છું, પહેલા terms લખી લો. Okay, why are we not finding this but we are finding this? Okay, next. KB, you know, T for what? Absolute temperature. Don't forget, that is temperature in Kelvin. અરે એની ડેફિનેશનમાં જ રૂટ છે, નથી ડેફિનેશનમાં રૂટ ઓફ મીન ઓફ સ્ક્વેર. So M stands for mass of a single molecule. Don't forget, confusion no create karta potana mind ma amthum. M stands for mass of single molecule. That's what we have been using. Okay, so પછી k ની વેલ્યુ ક્યાંથી લાવીશું? There is no need to write it like that. Okay, this is easier. So VRM is equal to under root 3 kBT by M. Okay, let's derive one more form of this. Okay, this form is of course useful. Let's derive one more form. So I will start from here, this step again. No, sorry, not from that one, the previous step here. I'll start from here. Right, let me just copy this step. Okay. So now we are deriving one more form of the same thing. Right. So I'll have to write it anyway. So this was equal to 3 RT by NA into N. Right, so this is what we have. Now instead of, listen to this, instead of putting R upon NA as KB, we'll go in a slightly different direction. So this is what we'll do. Do you remember that molar mass and number of moles have this relation? Okay, right? Also, hopefully you do remember once again that this is equal to n upon Na. Right, this is equal to n upon Na. So what we have got now is that m upon m0 is equal to n upon Na. Now I'm going to say that if you take total mass of gas, remember capital M is a total mass of gas. Total mass of gas is equal to mass of one molecule multiplied by number of molecules. Yes or no? Okay, so if we use this here at this place, here this place, we are going to get small m into capital N upon m0 equal to capital N upon Na. So what's cancelled? This is cancelled, and m into Na, therefore m into Na is nothing but capital M0. Capital M0 is the symbol of molar mass, right? So that is our next step. Okay, this step completely clear? do look at what I've done on the sides. Okay, it is the explanation, right? There is one more way to go about it. બે સ્ક્વેર રૂટ લીધું બે સાઈડ, રૂટ કેવી આવ્યું નહીં, સ્ક્વેર રૂટ બે સાઈડ લઈ શકાય ને. વી કેન ટેક સ્ક્વેર રૂટ ઓન બોથ સાઇડ્સ. ઓન પીપલ, okay, so we get this. Now there is one more way to get it. One molecule, its mass is small m. Okay, so if you take Avogadro number of molecules, then the mass is of course m into Na. But the Avogadro number of molecules, its mass is called nothing but molar mass, isn't it? Because Avogadro number is the 1 mole, right? Avogadro number means 1 mole of some substance. So that's the other way to do this thing. So m into Na becomes m0. Now, writing it in this form is easier. So once again, Vrms equals under root 3RT by m0. This is another formula of Vrms. Remember, both these formulas are always true. The one that we derived earlier, the one here. I'm going to write both together. They're always true. Okay? Right? What are the terms in here? m0, what is m0? Molar mass of gas. Molar mass of gas. બાકી તો બધું આવડે જ છે ને તમને, R એ આવડે, universal gas constant. Okay, so that is the formula for Vrms, right? This is what you need to know. Remember, you can use both of these every time. I prefer this one because generally we know the molar mass of gas. It's very easy to do it that way, right? Okay, now yeah, why are we finding Vrms? Why aren't we simply doing average? Okay, આવું ન કરાય, કરી શકાય ને. But Vrms is more useful. I'm saying that Vrms is more useful. What's the reason? The reason is, frankly, we don't care too much about with what speed a molecule moves. Remember, we really don't care too much about with what speed a molecule moves, right? But instead of the speed, what is more important is the kinetic energy that the molecule has, because ultimately the kinetic energy is related with the temperature. You understand what I'm saying? Speed of a particular molecule is not that important. On the other hand, the kinetic energy, the average kinetic energy of translation and all the other kinds of kinetic energy, they are important because they are all linked with temperature. So that's why when we take average of kinetic energy, listen to this, when we take average of kinetic energy, we automatically get Vrms. How so come થાય? I'll tell you why. Because what is meaning of average of kinetic energy? K1 plus K2 plus K3 added up to Kn divided by n, isn't it? Okay, so this is the average of kinetic energy and this is Kt average. I don't think anyone has any problem with this line. Clear or not clear? Okay, right? Just the average, plain and simple. Now, when you start putting these formulas, which formula? K1 is half m V1 square, K2 is half m V2 square, and like that. do you see we are automatically getting the RMS kind of formula? Okay, see, we are getting V1 square, V2 square everywhere, right? So, another way, a very quick and dirty way to derive VRMS is as follows. Okay, quick and dirty way, right? You can do this if you forget the formula in exam. બાકી derivation રીતે આ બરાબર નથી. So here is the quick way. See, average of translational kinetic energy of a single molecule is 3/2 kBt, isn't it? તો યાદ જ હશે. So we will write that simply as half m this. I will write I won't write it as half mv square. Instead of that, I will write it as this. Okay, average of v square, right? I am writing it as average of v square. Now I will ignore this thing, okay, and we will do calculations here. So I will get 2 to cancel, and I will get average of v square is equal to 3 kBt by small m. Now I will take square root on both sides. Right, I took square root on both sides. Clear? Now what is this left side? It looks something different, but it is same as VRMS. I'll tell you why. Square root of mean, triangular brackets means mean, average. Square root of mean of what? Of square. Whose square? Speed square. Understood that this thing is nothing but VRMS. Okay, so again, square root means r, root r આવી ગયો. આ triangular brackets mean of what? Of square of what? Square of velocity or speed, right? So that's why this left side is VRMS. અને આવી ગયો answer, VRMS equal to under root 3 kBt by m. I'm sure everyone would have liked this derivation, right? It actually hides all the mathematical complexity, right? Okay, હા, પણ એના માટે એક જ કન્ડિશન છે, તમને આ સમજ પડવી જોઈએ કે આ VRMS કેવી રીતે થઈ ગયું. ઓકે, every information is here in the symbol. root છે, mean છે, square છે, બધું છે. So it is VRMS. So this is VRMS equal to 3 kBt by m the whole under a root. એટલે આ આવી જાય તો ઓલી આવી જાય under root 3RT by m0. Okay, so this is the quick and dirty way. એક્ઝામમાં ભૂલી જાઓ તો આટલું લાંબુ ન કરાય, આટલા બધા સ્ટેપ્સ ન લખાય. એના બદલે સીધું જ એવરેજ કાઇનેટિક એનર્જી 3/2 kBt હાફ mv સ્ક્વેર મૂકી દેવાનું, એનાથી જે આવે એ VRMS. ઓકે, so now we are going to solve some questions related to this. Okay, so first of all we are going to have that example. First part આપણે કરી નાખ્યો હતો, હવે second part, right? So open your textbook if it's not already. What number was that? અરે વાહ, મારે સીધું ઈ જ પેજ ખોલ્યો. Example 13.5. Okay, example 13.5. Everyone ready? Part 2. Okay, let's begin. Root mean square speed means VRMS of molecules of two gases. Okay, we have to find, if you read the entire question, the question was you have to find ratio of what? Now this time we have to find ratio of VRMS. First gas is argon, second gas chlorine. So we have to find VRMS ratio for number 1, that is argon, divided that with this. Okay, question clear? This is what we have to find. right? Question clear or not clear? Okay, can you all hear me now? No, there was some connection problem, it got disconnected. Just 1 minute, okay, I'll do a thing, just 1 minute. Okay, can you hear me still, everyone? Audio is clear? Okay, very good. Right, fine. Now I'm going to share the screen once again so you can see. So here we are. Right. Okay, so we have to find the ratio of Vrms, that is Vrms 1 divided by Vrms 2. Right? For one is for argon and one is for chlorine, and this is a mixture that is two gases are mixed with each other, so they are going to have the same temperature. Remember, the temperature will be same. Right? Okay, so let's begin. We just have to find Vrms 1 upon Vrms 2. What's the formula? Under root, I am going to use the formula with capital M0. Okay, I like that formula because it is easy to use in my opinion. Very simple. Okay, so this is what we have. Temperatures are same. So do you see everything will get cancelled, and this is only going to be M02 upon M01. Okay or not okay? Right? Vrms formula, what is it? PRT upon M0, everything under a square root. Okay, so 3RT will get cancelled, M02 will be in numerator. So MO2 or M02, yeah, molar mass of second gas. Now what's the second gas? Chlorine. Remember, chlorine is Cl2. Chlorine gas is Cl2, it's not Cl. So let's put value 35.5, it's double. Should be 71. Is that okay? Molar mass of chlorine gas 71. Okay or not okay? If it's not given in question, then you should use your chemistry knowledge. Okay? Divided by MO1. Number 1 is argon. Argon no મને યાદ નથી આવતું. Helium, neon and argon. So 2, 8. શું આવે? 36 આવે? It's given in question. Okay, given in question. 40, 39.9 આપ્યું છે. So this is given in question as 39.9 and this is given in question as 70.9. Okay, in NEET please don't expect values to be given every time. Often you are going to see that values are not given. Some are given, but up to 20-25 won't be given, right? Okay, so you should try and remember the smaller one. So we just have to divide this, that's all. Equal to, just divide it in calculator or anyways and you are through, right? Don't forget to take square root as the final. So that's it, like we are done. So this is telling you that Vrms for argon, Vrms for chlorine is in ratio about 1.33. That's what people are telling me. The answer is yeah. So what does this mean? It's meaning here that argon molecules are fast compared to chlorine. right? Now why is that happening? Let me tell you. Let's try to get some meaning out of it. The reason is Cl2 molecules, their molar mass is close to 71. On the other hand, argon, its molecules have molar mass close to this 40. Okay, so these are heavy. You understand what I'm saying? These molecules are heavy. Heavy samajh pade na, they have more mass, right? But their kinetic energies on an average are same. How do I know kinetic energies are same? Temperature is same. આનો first part આપણે solve કર્યો હતો ને ત્યારે યાદ હોય તો એવું આવ્યું હતું that average translational kinetic energy depends only on temperature. So temperature તો બેયના same છે. યાદ આવ્યું ને? That's why KT is equal to KT. Do you remember that? Okay, hopefully you remember what we learned on Saturday. નહીતર તો પછી કેવી રીતે આગળ કરશો? So KE is same. So two things with same kinetic energy but one has more mass, that definitely means it is slower. समझ पड़ी कि नहीं? That means the chlorine molecules are going to be slower. Right? So that's the lesson to learn. At the same temperature, chlorine molecules, they are moving slowly because they have more mass. Right? On the other hand, argon molecules, they are moving faster because they are light. Okay, they can zip around here and there. Okay. Now let's go to the next question. The next question is in the exercise. Everyone, the next question is the exercise. Question number 7. Question 7 from the exercise. Question 7 from exercise is 13.7. Okay, let's get done with this very quickly. Estimate the average thermal energy of helium atom. Okay, never mind. I said we'll do it, but I think it will be better if we do it later. Not like you can't understand here, but it would be, perfect if we do it later, right? Sorry, we'll not do that. We'll not do the question number 7, right? Formula તો તમને આવડે છે, પણ એક concept એવો છે કે કહીશ તો તમને વધારે સમજ પડશે. Instead we can do question number 9. Exercise 13, question 9. Okay, so let's read that. At what temperature is the root mean square speed? At what temperature is the root mean square speed of an atom in argon gas equal to the root mean square speed of a helium gas atom at what temperature? At minus 20 degrees Celsius. Question clear to you? Look at this, what I have noted. That's the whole question. Question clear or not clear? We have to find the temperature for argon at which Vrms becomes equal to Vrms for helium. But this is for minus 20 degrees Celsius. And here we are not given the temperature. Question સમજાણો કે નહીં? I'm not so confident whether you have got it. ટેક્સ્ટ બુક લઈને તો બેઠા છો ને, એમને નથી બેઠા ને, કારણ કે આ વખતે હું દેખાડીશ નહીં ક્વેશ્ચન એક, બરાબર ને? એ બહાને તમે ટેક્સ્ટ બુક તો જોશો. Okay, so let's just put two sides. Always Resha absolute temperature is use karwanu, don't forget that. Okay, so let's put values. Formula of Vrms under root. Now here mass of atom is given. So if mass of atom is given, we should use this formula. I hope you understood that. Okay, because mass of atom is given, we can use this formula. Molar mass આપ્યો હોય તો m0 વાળી formula use કરી લે. So let's put values 3 kb. Temperature we don't know, divided by mass m of argon. How much is mass m of argon? 39.9. Do we need to convert u? You might have a question. The answer is no, because on both sides we're going to have the same unit. समझ पड़ी कि no समझ पड़ी? અહીંયા 39.9 and અહીંયા 4u. Yes or no? You don't need to convert. करो तो कहीं वांधो नहीं, but there is no need, because the units will always be removed or cancelled on both sides. Okay, so don't have to worry about it. તમને ખબર તો છે ને કે u શું હોય. Now what should I write here? This is for helium. Okay, this is for argon. Now what should I write here in temperature? Everyone tell me, come on, I'm waiting for you. You tell me what I should write. Temperature should be used in Kelvin. Remember, Celsius ma nahi, capital T. So this would be minus 20 che, so 253 Kelvin. Okay, and many of you got it. Yes, correct. Right. So now what's cancelled further? What's cancelled? We can remove root by squaring both sides. 3 cancelled, kb cancelled. So T upon 39.9 equal to 253 upon 4. बस अब आना solve करो એટલે answer આવી જશે. That is for you to complete on your own. Remember, the final answer will be once again in Kelvin. Right? Final answer once again in Kelvin. Okay. So that is about Vrms. Right? Okay. So here, let me give you one additional question not given in the book. Here we go. It's that if you say RMS speed for a gas at 27 degrees Celsius is, let's say, 500 meter per second. Okay. What is the speed? What is the RMS speed for the same gas at 1127 no 927 degrees Celsius. Come on, solve this question. Hurry up. You have 1 minute only. Only 1 minute. Very simple question. No, Resha, wrong answer. Are you sure, Ron? 927 છે. No, nobody has got correct answer yet. Now I am doing it. Okay, first thing to do is the temperatures. They are supposed to be in Kelvin, don't forget. So one is 300 Kelvin. Okay, and the other is 1200 Kelvin. Yes or no? Is this clear? 27 plus 273. Okay, so that will make it 300. 7 plus 273. and similarly 927 plus 273. So now we will use the formula for Vrms. Case 1 upon case 2. Okay, case 1 upon case 2. Under root 3 RT1 by M0 under root KBT karo to એ ચાલશે હો. Don't worry about that. Both the formulas are always true. So now this is what we have got. Now same gas, so M0 cancelled, 3 cancelled, R cancelled. So this is simply under root T2 by T1. Now we want to find what is V2. V1 500 meter per second, V2 unknown, equal to root of T2 by T1. T2 by T1 is 1200 divided by 300, so that is 2 after taking square root. Okay, so T1 by T2, T2 by T1 આવે. Okay. Oh, sorry. Excuse me. Yeah, I'm so sorry. मैं ऊंधो रेशियो लीधो. Yeah, agreed. T1 by T2. That's right. So this is equal to 300 by 1200. So that is 1 upon 2. Okay, this is equal to 1 upon 2. Right? So that will give you V2 equal to 1000. Right? That will give you V2 equal to 1000 meter per second. Understood? $10,000 1,000. Right? 1000 meter per second. So this is how you can solve such questions, right? Which are based on VRMs. Okay? Now let's go to the next thing, and that is solving some basic questions of gas laws and all that. Okay, એમાં કઈ નથી એવા ક્વેશ્ચન તમે કેમિસ્ટ્રીમાં કર્યા જ છે, right? So there are some questions like that, some question like that given in the exercise, I think. Okay, here question 13.1 exercise point. ના જે હવે બહુ નો આપી શકાય, આમાં કઈ નતું, ખાલી આવી ફોર્મ્યુલામાં વેલ્યુ મૂકવાની હોય. ઓકે, estimate the fraction of molecular volume. Question 1 from exercise. Estimate the fraction of molecular volume to actual volume occupied by oxygen gas at STD. So we are given that there is STP, standard temperature and pressure. Gas is oxygen gas, and we have to take diameter of molecule. Suppose this is oxygen molecule which is roughly spherical. It's not, I know it's not spherical, but I question may assume current, right, that it is a spherical molecule with how much diameter? Diameter of this molecule is 3 angstrom. Okay, so the question is estimate the fraction of molecular volume to actual volume occupied by oxygen gas. What does that mean? First of all, suppose you think that there is a vessel. You know that in a gaseous phase of matter, what happens is that the molecules are actually occupying very less space, and there is large distance between the molecules. Do you know this? There is a lot of empty space is there. Are you aware of this? Okay, if you are not, don't worry. Our question might શીખવા મળે. Okay, so what does the question mean? Fraction નો મતલબ ratio. Once again we have to find a ratio of what? Of molecular volume. Molecular volume no meaning to that means volume of the molecules. Okay, molecular volume means volume of the molecule. So we have to find a ratio of the volume of the molecules to volume of gas. Did you understand the question? Between ratio of volume of molecules and the volume of the gas. See, how are these two different? Let me explain. Suppose you all are sitting in a room. Okay? Then your bodies will occupy some volume, but there will still be some empty space. No, they are not there. Please some doubt. Your bodies will occupy some volume in the room. Okay, but it doesn't occupy all the volume in the room. Did you understand? Okay, so that's the difference. Volume of gas actually means like volume of content. Okay, because you know the gas spreads out everywhere. But the molecules are only occupying some small spaces like this, and between the two there is lot of empty space. Did you understand this? Right? So they are not same. Right? There is lot of empty space. Now, this is the ratio that we have to find. Right? How much is the volume of the molecules and divided by how much is the volume of gas? Right? Hopefully you got this analogy. Gas is everywhere, but between the atoms there is empty space. Right? Between the atoms there is empty space. Don't forget that. And atoms are continuously moving. That's why some molecule or the other will end up inside your nose and you will be able to breathe. Okay. If all the molecules would be stationary, then we would not be able to breathe. That's what I told you, if you remember last time, right? Okay. So volume of the molecules divided by volume of the whole gas. Now, why you had taken volume? Question might be the volume. The volume this. Check with that. Yeah. So now, suppose there is one more. See, this answer, this is your answer. This answer does not depend on the quantity. What do I mean? If you take 1 mole of gas, if you take 100 moles of gas, if you take 1000 moles of gas, still this answer will not change. Right? You will see that when we derive. Okay. So suppose the molecules be mu. Now one is so easy. Cover for this. Let number of moles, let number of moles be 1. 1 number of 1 mole. Okay. Therefore, volume of 1 mole of oxygen gas at STP. આ તો તમને મોઢે આવડતું જશે ને કેમિસ્ટ્રીમાં આવે છે ને વોલ્યુમ ઓફ 1 mole of oxygen gas at STP is how much? So there, how much volume for 1 mole of gas? 22.4 liter. Okay, it is 22.4 liter. Now, liter is not a unit that we like, so we will convert it to meter cube. 1 liter is 10 raised to minus 3 meter cube. Right? So, I converted 1 liter to 10 raised to minus 3. Okay. Now, once you have got this, in a denominator figure, do you understand why I took 1 mole? If we take 1 mole easily, we can find the denominator. Right? Okay? So, we don't have to worry about anything. Now, what about volume of molecule? Let's start with this. Volume of molecule. So, volume occupied by molecule is fairly simple. Number of molecules multiplied by volume of 1 molecule. Okay, I'm sure you understood that. So let's multiply. Number of molecules in 1 mole, Avogadro number, that is Na. And volume of one molecule, because in question it is given that we have to take it to be a sphere of this much diameter, right? So that's why we will do it as 4 by 3 pi r cube. Okay, this step clear? Radius is 1.5 angstrom. Diameter is 3 angstrom. So radius is 1.5 angstrom. So volume of sphere is 4 by 3 pi r cube. So we just multiply this 6.02 into 10 raised to 20 to this. Okay, so whatever we are getting here, leave it like that. Okay, so this is numerator. So our final answer, the required fraction or required ratio is equal to this whole thing, the numerator, right? And divided by 22.4 liter, that is 22.4 into 10 raised to minus 3. Right? So this is whatever this turns out to be is our answer. Right? You are going to find that it's very small. You are going to find that it is quite small. Okay, we will discuss the implications of the answer in the evening, right? So make sure you get the answer by that time. Okay, radius, diameter 3 angstrom, so radius 1.5 angstrom. Okay. Also, there's one thing that I want to point out is that suppose you take more moles. Suppose instead of 1, let's say you would have taken 3 moles. Then here we will have to write 3. If you write 3 here, this would also become 3 times. And if that becomes 3 times, on the other hand, your number of molecules will also become 3 times. You understand what I'm saying? So અહીંયા into 3 આવે તો અહીંયા into 3 આવે. Still the answer would be same. Right? So that's why I told you that it doesn't matter how many moles you take. The final answer will always be the same. એટલે આપણે 1 mole લઈને easy કરી નાખીએ. Right? Why to make it tough by taking 3 moles or 5 moles or something. Okay? So make sure you find this answer. I know it's going to be small, right? And we will discuss what is